So this is lesson 1.7 in elementary algebra, properties of real numbers. Alright, so I'm not going to expect you to memorize all these properties. Some of them you already have used in other math courses and you didn't even know what the names of them were. And my big thing that I want you to get through to you in this section is just how to use the properties. Not necessarily knowing that I use the commutative or the associative or the distributive, but just be aware of how to use those. The first one that they give us, and I'm just going to go through a little bit of theory, so just bear with me here, is the commutative property for addition. And that says that if we take 3 plus 5, that is the same as taking 5 plus 3. It just means that when you're adding two numbers together, it doesn't matter what order they're in. The same is true with multiplication. 3 times 5 is the same as 5 times 3. Okay? So again, it's one of those things that you probably already know and already use, but just to give you the name. Commutative property of addition, commutative property of multiplication. Alright, the commutative property does not work for subtraction and multiplication. For example, 5 minus 3 is not equal to 3 minus 5. Did I say multiplication? Division. So subtraction does not work and division does not work. 5 divided by 3 is not the same as 3 divided by 5. Okay, you can't switch the orders around in subtraction or division. So it's just addition and multiplication. Alright, so that helps us when we have a long strand of numbers together. Okay, so you can start from left to right and go, oh, 3 plus 5 is 8, 10, 16, 20. But some people look at this and go, oh, this is 10, and this is 10. 10 plus 10 is 20. Okay, so it doesn't matter what order. Multiplication, you seem to run into it a little bit more when you have something like this. And you may be, well, 3 times 5 is 15. 15 times 6, oh, dang, where's my calculator? But if you do 5 times 6 is 30. 30 times 3 is 90. You can pretty much do that in your head. So that's when it becomes convenient, is quick multiplication in your head. It also becomes convenient when you're doing things like 5 plus x plus 3. Okay, you've just got some simple addition. But one of the things that, if you remember from previous courses, is you cannot add letters to numbers. All we can do is add the numbers. So you can just skip the letter and just get 5 plus 3 is 8 plus x. And that ends up being the simplification of what you're doing. And that can also be written as x plus 8. Doesn't matter what order. In fact, usually the variable comes first. Alright, so isn't this just fun? Alright, let's continue on. We've got the associative property of addition, and really all that is grouping. 3 plus, let's put a plus sign. 3 plus the quantity 2 plus 5 would be, and remember PEMDAS, you do what's in the parentheses first, and you get 10. I could also write this as 3 plus 2 plus 5. Do what's in the parentheses first, and I also get 10. So it's just how you group things. You can mix things up. You can group the 2 and 5 together or the 3 and 2 together, and you've done that all along. Sometimes you're just not aware of what you're doing. You're just doing it. And the associative property of multiplication is the same thing. Okay, so that gives you 3 times 6, which is 18. Or we could do the 3 times 3 in that grouping and multiply that by 9. 3 times 3 is 9. 9 times 2 is also 18. So that's the associative property for addition and multiplication. Again, it only works for addition and multiplication. So if you have something like 4 plus, and this is example 2, okay, you can just add the 4 and 5 and be done. Okay, if you have negative 5 times 2x, okay, you just multiply the numbers and get x tagged on, because you can't multiply a number and a letter, you just stick them side by side. Or if you have 6 times negative 5y. What the book shows is happening is you do this in the grouping symbol and take the y out. What I do is I just multiply the numbers times the numbers and let the letter or the variable just kind of follow along with it. But that's the associative property. Let's continue on with this when we have example 3, 1/5 times 5x. Okay, we're just multiplying the numbers here. So 1/5, and if this helps to write 5 as a fraction, go ahead and do that. And then you multiply numerators, denominators, tag on the x, and any number over itself is 1x, and you don't even have to show the 1, you just show the x. And B has a -2 times -1/2 x. And they make a really, really big mess out of this when they're showing how to do it. And to me, it just makes it complicated. This is what they do. Okay, kind of messy. What I suggest doing here is just multiply the number times the number and be done with it. So we'll put that over 1, multiply my numerators, a -2 times a -1 is a +2. 1 times 2 is 2. Any number over itself is 1, so we can just cross it out and make it go away, and you're done. There's nothing fancy, nothing complicated with all those brackets and braces and parentheses. 12 times 2/3 x. Again, if we want to make that into a fraction, we can, to remind us to multiply the 12 times the top number, bottom number. 24 over 3 reduces to 8, and we get 8x for our answer. Okay, so basically when you're multiplying letters and numbers, you multiply the letters times each other, you multiply the numbers times each other, and that's pretty much what you're using the associative property for. But there is another property called the distributive property, and what that is sometimes you will have a number and you're trying to multiply it by a parenthesis of numbers like that. What that means is 3 is multiplied by everything in here. It's not just multiplied by the x, it's not just multiplied by the other 3. In fact, I'm going to change that to a 4 just so that we don't have 2 3's there. So this means take 3 times x. Again, you can't multiply a number times a letter, so you just stick them together. And 3 times 4, and it will have this sign there. And the reason it has the sign is because that's a +3, and a positive times a positive is obviously a positive. If I had -3, okay, multiply those two, stick them together, and then we multiply these. What's a -3 times a +4? A -12, and you get that for an answer. And usually if students are going to have any kind of a struggle, they have a struggle right here. They multiply 3 times x, but they don't multiply the 3 times the 4. And just something else to remind you, if you have something like that, that 3 is being multiplied by everything here. So we end up getting 3x plus 3y, again, stick them together, number and a letter. 3 times 2 is 6, 3 times 6 is 18. Then we can multiply or add those together and be done. Notice, we cannot combine these. You cannot add different letters together. Okay, so I said you can add letters, you can add numbers, but the letters have to be the same. Numbers don't have to be the same. 6 plus 18, and they're not the same, but you still get 24. But an x and a y can never be added together. It really can't even be multiplied. If you have x times y, you just stick them together. You really can't do anything with them except leave it as x times y. But that's another lesson. All right, I am not going to show you the whole method thing as far as using the triangle, method 1 and method 2 on page 79. I personally think that makes math more difficult when they show some of these pictures, especially when the pictures don't really make a whole lot of sense to me. But go ahead, example number 4. I'm going to let you try some of these on your own, but let's at least do D. That's probably the hardest one. 3x minus 5 minus 8. We look in here, can we do anything there? No, we have a letter and a number. You can't combine a letter and a number, so we did the parentheses in PEMDAS. Now we're going to do multiplication. Well, this says to multiply 4 times that and 4 times that. So negative 4 times 3x. What's negative 4 times 3? Negative times a positive is a negative. 4 times 3 is 12. And again, we tag the variable on the end because we can't multiply a number and a letter. Now we multiply the negative 4 times the negative 5, and we get plus 20. And then that negative 8 just kind of follows along after we take the parentheses off. So I have negative 12x, and then I have this here. My biggest number is positive. The signs are different, so I take the difference, and I get that for an answer. Okay, and that's pretty much it for D, and that, again, is the harder of the examples there. Okay, so let's keep going here. Example number 5. They're starting to get a little more complicated because they're using fractions, but we have 1/3, negative 1/3. Okay, so again, we are going to multiply this times that and this times that. Alright, so again, if it makes it easier, we'll make our whole numbers into fractions so that when we multiply the 1/3, we know that we're multiplying the 1 times the 2 and the 3 times the 1. And a negative times a positive is a negative. So we'll put a negative. 1 times 2 is 2. 3 times 1 is 3. And we tag the x on. Alright, so let's look at the negative 1/3 times negative 6. Or we just changed it to 6 over 1. Negative times a negative is going to give me a positive. 1 times 6 is 6, and 3 times 1 is 3. Now I look at my 2/3, and it cannot be reduced, but 6 over 3 can be reduced to 2. 3 goes into 6 twice, and that ends up being my answer there. So this is example 5D, so let's go ahead and distribute that. Again, everything is done the exact same way. And if you need to make that into a fraction, make it 12 over 1. We multiply the 12 times the 2 and the 1 times the 3. So the 1 times the 3 and the 12 times the 2. And then we stick the x on it. Now we multiply the 12 over 1 times this 1/2 right there. So 12 times 1 is 12. 1 times this 2 is 2. And we tag the y on. Now we look at the numbers in front of the x and in front of the y and see if they can be reduced. 24 over 3, or 24 divided by 3, is 8. And 12 over 2, or 12 divided by 2, is 6. And we are done there. Let's look back at C. Sometimes when they start throwing in all these letters, it can make it a little bit confusing. So we have A times 1 plus 1 over A. Okay, so A times 1. Anytime you multiply a letter or a number times 1, it's itself. It doesn't change. So A times 1 is just A. Plus A times 1, and we can make that into a fraction. A times 1 is A, and this 1 times this A is A. Anything over itself. It does not matter if it's 3 over 3 or A over A. Anything over itself is 1. And there ends up being your answer there. Alright, well, I'm going to continue with example 6 in the next video. I'm running out of time here, so 1.7a is complete.